All right, in 10.3, we're going to learn a new type of interest called compound interest. This one is a lot more realistic because most of the time, whether you have a savings account or a certificate of deposit or anything you can do at the bank or a loan, a lot of times it's compound interest. All right, and what this means is that, let's say, just for a really simple example, if you have $100 and 5% interest, okay? Let's say you're going to leave it in for 2 years. So for simple interest, you would take 100 times 0.05 times 2, all right? And you'd get $10 for your interest. So you would have $110 in your account if you left it in there for 2 years. Now for compound interest, and it depends how many times it's compounded, which we'll look at, but just to, again, make this a simple example, if it's compounded yearly, what they do is you have to, kind of like we did in 10.2, where you break it apart. So you would do $100 at 5% for 1 year, so $5, which means you would have $105 in your account. Then for year 2, then you do 105 times 0.05 times 1. All right, so then you actually make more money. So compound interest is good for savings accounts and things like that, but it's bad for loans because you accrue more interest if you do it that way. Okay, so compound just means they figure the interest more frequently, and you add on your interest for your new principal, whereas your simple interest, it didn't matter if you left it in there for 2 years or 20 years, you still only start with the principal that you started with. Okay, so here's the formula. A equals P times parenthesis 1 plus R over N to the N times T. Okay, so A is your amount, or like I call it, the account balance. So that's your final amount. So this one's a little bit different. Simple interest, you calculate the interest and then have to add that on to get your principal or to get your total amount. This one already gives you your total amount. So if they ask you how much the interest is, you have to subtract it out. Okay, P is your principal again, which is your starting amount. R is your rate. This one has to be in years. N is the number of times compounded in a year. Okay, and we'll look at a couple of different examples so you can see what that is. And then your T is time in years. All right, so we're going to look at page 589, number 20. Okay, so winning $2,500, so your principal is going to be $2,500. Actually, I'm not going to write it all out this time. So A equals, your principal is $2,500, 1 plus, your interest rate is 3%, so 0.03 over, it's compounded monthly. So monthly would be 12 times per year. So 12 there, and then 12 times 4 years. Okay, so again, you can plug this all into your calculator just like this. There's one thing you have to be careful of. If you are going to leave this as 12 times 4 rather than 48, then you have to put that in parentheses also. Okay, so you need the parentheses where they are, and then if you leave this as multiplication rather than doing the multiplication on your own, you need to put that part in parentheses. Okay, we should get 28, 18, 32. All right, now we're going to do number 24. Same page. Now we have $5,000 as our principal. 1 plus 3.35, so 0.335. Compounding quarterly. Quarterly means 4 times a year. And then for 5 years, so 4 times 5. Again, if you just want to make that 20 right off the bat, that's fine. Then you don't need parentheses. If you're going to leave it as 4 times 5, then you do need parentheses. $5,907.60. Then we're going to do number 28. This time we're starting with $1,055. 1 plus 1.8%, 0.018. Compounded daily. Again, even though there's 365 days in a year, we use 360. So the banks use 360 for a year rather than 365. Okay. To the 360 times 3. So again, make sure you add parentheses in there unless you're going to do it separately. And that gives us a total of $1,113.53. Okay, so again, hopefully these problems should be a lot easier and shorter than what you had to do in 10.2. All right, there's one other type of problem, and this is going to be on 590, number 36. So this is something called present value, and there's technically a present value formula, but I don't like to do the formula. It's a lot easier just to set it up the same way. Okay, so this time they don't give you a principal. They're asking what your principal would need to be. So you need $26,000. You have to figure out how much you need to put in order to make that happen. Okay, so 26,000 equals P times 1 plus 2%, 0.02. Quarterly is 4. 4 times 15. Right? So here's what you do. I do not want you to type this in and round it. Okay, you will get it wrong if you type that in and round it. This whole thing right here, this is one thing being multiplied by the P. So to undo multiplication, we need to do division. So I usually make that 60 or whatever I do the multiplication just so it's one less set of parentheses. Again, if you want to keep it as 4 times 15, you're more than welcome to. You just have to make sure you put parentheses in there. So your calculator is going to look like this. 26,000 divided by, my calculator does divided by like that, parenthesis 1 plus 0.02 over 4 to the 60th. Again, if you leave it as 4 times 15, that's fine. Just put parentheses like this. Okay, and you should end up with $19,275.68. Okay, so obviously whenever they ask you how much do you need to deposit or something like that, your answer better be lower than the amount that they give you. All right, so that's it for 10.3. Some practice problems would be page 589, 19 to 27 odd. And then page 590 is going to be 35 through 39 odd.